And this problem is largest palindrome product. And number 4 of Project Euler questions. A palindromic number reads the same both ways. So for example, 99 is a palindrome number, or 101 is a palindrome number. And here the largest palindrome that made from product of two digits number is 9009. And for example, numbers like 101 are palindrome because they can be read from both sides the same way. Or even numbers like 121. From both sides, it's 121. So we call these numbers a palindrome number. And here there are some special palindrome numbers that we should take care of. Those that are made by product of two other numbers. Like for example, 91 times 99, which is 9009. It could be read from both sides the same way. And here what it asks us to do is to find the largest palindrome that made from the product of two 3-digit numbers. So it's actually, there are two questions that we should solve. First, writing a function to check if a number is palindrome or not. I call it is pal for if it's palindrome or not, which should be a Boolean function. And we need another function to create a product of those 3-digit numbers, and that could go from 100 to 999. And because it's easier to write the checking of palindrome function for strings than integers. So first, that function gets an input as an integer, and then integer just as in, and then it will convert into a string as str, and then it will check if the str is palindrome, then it's true, else it's false. How to check if a string is palindrome or not? So we should, for example, a string like ASA is palindrome, and strings like zoo are not. So how to check if it's palindrome or not? We should start from the first index and check it until the middle of it. So for here, we have 3 digits, then we should check only the first one and the last one. If they are the same, then everything is fine, because the second one is always the second one. But if it's an even number, like so there are 6. So we should check if 1 is equal to 6, if the string under 2 is equal to 5, and 3 equals to 4. So we just need to check from 1 to 3 with 4 to 6. So here is the function that checks for that. It's a Boolean function, so it returns true or false. The name is pal for is palindrome, and then it gets an integer. In this special case, we just need to check for a palindrome for integers and not for strings. So I get only integers. And then it converts that number as an integer to a string. And in a for loop, it starts from the first character and until the character that is in the middle of that string. So to get to that, I find the length of that string and divide it by 2. and it goes one by one until that point. So I check the character at the position of I with the character that's at the position of at the opposite position on that string. So and to get to that, I did this. For example, imagine that here we want to check the 2 and the one which is on the opposite side. We know that the integer length is 6, so 6 minus 2, it gives us 4. But here we know that that it starts with 0, not with 2. So we should convert that to be to 0. So we have minus 1 to change everything. Start from 0, not from 1, as is here. And then I check if they are not equal, I will return false. And I go through all the characters, and at the end, if nothing bad happens, then it's true. So our number is palindrome. And then it's just a brute force, and it's a brute force method to check all the 3 digits. They can be multiplied by other 3 digits to check if that's the maximum palindrome number or not. So first, I define a variable named max, and I initialize it by value 0, because nothing is smaller than 0 for positive integer numbers. Then there are 2 for loops, and one starts from 100 to 1000. The other one starts from the I as a variable of the previous loop until 1000. Why I started with I? Because if I don't start it by I, there might be like 900. It will check 999 times 100. But it's already checked, so I decided to use I as a initial point, and then I will check if that number is palindrome and it's bigger than the previous maximum. So I will change the maximum to I times j, which is our new number that we reduced with the product of two other 3-digit numbers. And I will go through it to check all the numbers and to find the maximum palindrome number that is made by a product of 2 into 3-digit integers. And then I will print it out. So and if you run it, it will the result is 906609, and it's a 6-digit number, and the 3 at the first and the 3 at the last are mirrored. So this is a palindrome. And if we check this one, we'll see the same answer here, and that's it.